Okay. So today we are in the second day of our international faculty development program or the international webinar. And good evening to all the participants and very good morning to the speaker.
Good morning, Ushaa.
Good morning. Nice to have you today. And let us start the session. Industry 4.0 is our theme. So Industry 4.0 and IoT are key elements of the digital revolution. Digitalization is advancing at a rapid pace, and innovative pioneers are successfully defining and implementing digital agendas. What could only be imagined a few years ago can now be seen in new disruptive business models that are redefining entire industries. Organizations now face the reality that the technological revolution can no longer be stopped. Industry 4.0 and IoT defined as intelligent, interconnected equipment and products autonomously communicating and optimizing along the entire value chain are key elements of this digital revolution. IoT enables automation as never before, with machines making split-second decisions based on real-time data. Industry 4.0 gives you not just smart factories, but also tremendous data to facilitate decision making in product management and product engineering. So today we have a wonderful guest with us who is an expert in the topic which we are discussing about, and he's going to throw a lot of light on this particular area. And he's none other than our Raja.D.Singh, and he's a president of SIRIUS. How do you pronounce it, Raja?
You did it right. SIRIUS MICROTECH.
MICROTECH LLC. And Mr. Singh has led international teams of engineers in developing has been a lot of innovative new product development efforts with high growth technology companies that are spanned across the globe. And Mr. Singh has led international teams of engineers in developing intellectual property for solving demanding problems within semiconductor, automotive, and process control industries. With this experience and expertise, he established SIRIUS MICROTECH LLC in 2007 to support companies with effective and reliable new product development efforts. From inception, SIRIUS MICROTECH has helped clients with as little as single line descriptions of their next big data. And SIRIUS MICROTECH is comprised of engineers who live and breathe technology and of managers who understand the bottom line. SIRIUS was founded by Mr. Singh with complementary skill sets in electrical, embedded system hardware, firmware, automation and control systems, database and application software. And Mr. Singh is well trained in new product development methodologies and statistical process control and Six Sigma. And SIRIUS MICROTECH entered into a strategic business partnership with Hydrospace Group in the field of undersea vehicles, manned submersibles, and subsea control systems. And SIRIUS MICROTECH has supported Hydrospace in several national and international manufacturing projects, from 3D holographic display systems to high power propulsion and control systems with custom diagnostic software for operation and testing. The current developments include a range of special projects related to IoT and distributed networking. And this includes remotely operated electromechanical subsea oil production control valve systems for next generation field production systems permanently installed on the ocean seafloor. And he is an active partner in every aspects of product life cycle, starting from conception to end of life. And he enjoys designing special purpose capital equipment custom hardware using microcontrollers, FPGA, CPLDs, and single board computers and embedded Linux. And he is involved in innovative new products within the field of IoT using wireless sensors, data logging with GPS, and cloud technologies and M2M applications. And I'm very happy that he had visited India and we had the opportunity to meet. And I'm also proud to say that he was my first boss. When I just completed my BE from Annamalai University in 1989, I joined a company where I was a trainee engineer and he was my team lead. And we were into the project of barcode reader design. And he is my guru. Whatever I'm today, he has just started everything for me. And till date and for future, he is definitely going to my guru, well-wisher, and very good guidance I get from him, and a moral support he supports all the time. And I'm very, very happy, extremely happy to have Raja here for our session today. Welcome, Raja, and over to you.
Thank you, Dr. Ushaa. You want me to start sharing?
Yes, please.
Can you see it okay?
Yeah, but it's not playing. Is that the format?
Sharing is paused. Bring your shared window. Okay.
No, you need to play. I think.
Yeah, I am playing it. For some reason, it's not coming to the front. What is... okay, your screen sharing. What? Technical difficulties. Hang on a second, just a minute. Can we just stop sharing now? Share screen, no point.
Yeah, great.
Okay, good. All right. Hello, everyone. Hope all of you can hear me okay.
Yeah.
My name is Raja.D.Singh. You're going to spend the next hour with me on this topic. But before we dive into the talk, first off, I would like to give a big shout out to Dr.Ushaa Eswaran for pulling through this spectacular faculty development program series for these couple of weeks. I'm pretty sure that all of you appreciate getting exposed to different perspectives from different people around the world. I also would like to thank Dr. Ushaa for a very generous introduction of me. I mean, she's great. You all know that. I don't have to talk about her to you. All right, so in that line, I will try my best to let you get into a perspective which is different from what you take every day. So with that said, my goal for this talk is to get ourselves into thinking like an embedded systems engineer who is in real life, he's a part of a team which is involved in IoT product design and development. So hypothetically, we're going to assume that this team is tasked to design an IoT product. And basically, we're going to design this product in this talk. We're going to be hands-on. Every one of us are going to just think about all the discussions this team is going to have, all the design decisions this engineer is supposed to make, how he arrives at those decisions and all those things. Hopefully, this is going to give you a perspective of this engineer particularly embedded systems engineer, not the cloud side of it. It's only on the device side of it. But if you are interested, if time permits, during the question and answer session, I would be more than willing to talk about cloud technologies and how this IoT products will pan out into that context as well. But before we get on to the design process, which I mentioned here, we will explore some relevant topics a little bit to get familiarizing ourselves with the context in which this design team and this engineer is operating on. I hope this is of interest, and let's get started. A little bit about me. These are quick facts about me that might be of help to understand today's subject, basically. Growing up and even today, I always wanted to know how things worked. So what is under the hood is my question always, like when I look at everything, just wanted to pull them apart and see what ticks underneath. So the technique that worked for me to understand complex things was to reduce them to simple first principles by looking at them from various different angles or different perspectives. So that's why we are going to be talking about a perspective today about from an embedded systems engineer. I started my career as a hardware engineer, designing digital analog and microprocessor and microcontroller based systems. I don't know how many of you are old enough to know there existed devices called PALs and PLAs and PLDs. They are no more. They are superseded by FPGAs now. So these are the precursors of FPGA world, PALs and PLAs. All right, I thought it would be funny to mention that. Anyways, expanded over to firmware and software, built some serious electromechanical systems, automation, machine building. These are precision machines used in subsea systems, semiconductor industry, Industry 4.0 related machines. I'm an electronics and communication engineer. I'm a senior member of IEEE. For the past 13 years, running SIRIUS MICROTECH LLC. It's a small engineering design house. We call ourselves as a surgical team. As Dr. Ushaa pointed out, people come to us with one single line and say, like, what if will this work? And we take it up and we just prove the concept, come up with minimum viable product, MVP implementations, and then take it to market. So we do the whole enchilada in California talk, the whole 9 yards. So my attitude to go work every day is work is for fun. That's my attitude. All right. Having said all that, let's get into the talk. What is without humor? We have to have a little bit of humor, right? So a picture worth of thousands of words. Here we see two perspectives. In this, obviously one of them is wrong, but it's not that easy to point out who's wrong here. As you guessed it already, this is not the perspective that we are going to be discussing in this talk today. Instead, we will be talking about somewhat similar to this perspective. You know, the stick figure in this comic is tossed between two different perspectives. One is that of a user who just uses a browser, Firefox, and sees that, oh, what's a big deal? It just serves web pages. Well, why would I what else is there? On the other hand, if this stick figure it looks like he or she is a software engineer as well. That perspective kicks in, and the stick figure thinks, oh, it's an excellent piece of work, and put together by excellent people in the open source community. So these are the two perspectives, but about the same thing. So this is what we are going to be talking about. So I have another simple example for perspective. So you drive a car, and a ar from the driver's perspective is it takes point A to point B. The driver just goes point A to point B, and the driver is needs to know accelerator, brake, clutch, not so much of clutch anyways, and steering. So that's all it is, driver's perspective. A mechanic's perspective is components, ignition, fuel system. You get what I mean. So this is how we are going to approach today's talk. All right. I sprinkled this presentation with these kind of comics just to make this subject a little lighter, but I don't know if this is going to serve that purpose, but anyways, we'll try. Yeah, we got to define what is the Internet of Things. Basically, so we take our own approach here. Let's not pay attention to what we read about IoT. We just ask some questions here and see what kind of answers we come up with. Question number one is this a specific field of technology? No, IoT is a complex, multidisciplinary effort. There were pioneering efforts before this. They were called in different names: pervasive computing, embedded internet, M2M, even Industry 4.0 is one form of IoT. It is not IoT, but it is one form of IoT. So that's why Dr. Ushaa put it rightly that it is a disruptive business model, not a disruptive technology. So she said it already, what I'm supposed to say here. Thanks, Ushaa. Originally, okay, this is a business model, right? So it's not a disruptive technology. It is more of a system integration effort. So you take all kinds of existing technologies and put together and keep working on it, improving every technology. A lot of improvement is made in the area of sensors. Sensor development is a key element in IoT, because you have to translate your real life world parameters into data, which is where sensors come in. You said a box. Okay, I got to tell you a story here. I was invited into a big computer manufacturing company in US. I'll tell you which company when you ask. I'm not going to say anything about that company right now. Say that they called me in and they wanted to. This was 6 years ago. They were like, they heard about IoT now and they wanted to be there. Like, hey, we want to be on the bandwagon of IoT. What do we do? And I was looking at bunch of executives and with their papers and pencils ready to take notes about what is IoT. And one guy asked, is that a board we design? And I said, no. And then there's another executive says, oh, okay, so it's a hub which we connect all the sensors, right? And I said, no. And there's another lady, she comes and says, okay, it is a box, right? So we're going to put it right next to the Wi-Fi router, right? And I said, no, it's all the above. So you just have to, you cannot define this one single thing. So it is a combination of many different disciplines. Um, so by looking at all this, we come to a conclusion that it is networking of devices, or in other words, networking of information. Basically, we are going to be Internet of Things is networking of information. That's what we're going to pound on in this session here. Okay, there's another cartoon. I realized that it's kind of too much to read through, so we'll skip this. There's a guy who's getting excited about his network which he built. That's all. So basically, I wanted to say what is the significance of a network in networking information. So I put that thing there, anyways. So from the earlier slide, we concluded that IoT is an expanding scope of computing. What happened to? Okay, I just wanted to go back to this slide a little bit. When we said networking of devices and networking of information, before we expanded out to a network, we had localized computing resources. If you open up a computer, you see a computer motherboard, and there are lots of peripherals attached to the central microprocessing unit over different buses like PCI, SPI, I2C, all kinds of buses are there in that computer. Imagine that those buses are networks as well. So that right now we are expanding our scope of this network outside of that board. Basically, that's what we're doing. This idea of expanding to a network and expanding your computing has been a slogan for a company called Sun Microsystems. You all remember this company. I was fascinated by their foresight in their slogan. Network is the computer is their slogan. They used to, they knew it, like this is going to happen. So that's why they came up with a language for it, which is Java programming language. Actually, the original intent of Java programming language was to write once, run anywhere, especially in embedded electronics. The goal was to develop a small, reliable, portable, distributed real-time operating platform. That was the goal with which Java was originally conceived of. Later on, the developers community and IT people saw the portability aspect of it and pounded on that one particular aspect more than anything, and Java became a sensation among developers, developer communities. We're not here to talk about Java as well, so but let's keep that in mind, that there was a company which had foresight into saying that networking is the computer of future. Okay, when we talk about networking of data, we need to talk about data as well. There are some dangerous data also. We'll get to it now. So devices collect real-time data using sensors, which we already know. Sensors are, when you bring it down to first principles, sensors are basically they convert one form of energy to another. In our case, it's always electrical energy, which is what we are interested in as electrical engineers. The electrical representation of real-time parameters are processed by required circuitry to get a meaningful data. So when I say that, when an embedded system developer designs some device, he is interfacing the device with different sensors. He has to build in circuitry which will process that sensor data. Just to give you an example, let's say you have an IoT device, which is a motorcycle control. This motorcycle control IoT is supposed to give you proper ignition cycle by looking at spark plug output with respect to the engine cylinder position, let's say. Most of the motorcycles are operated by 12-volt battery in there. So your circuitry should operate in 12-volt level, whereas the spark plug is going to give you in kilovolt region. So you got to have some processing circuitry in your design. That's the goal. That should be one of the goals of the embedded systems designer who's looking at this design. Sensor data, you can't just take data alone. You have to have more than one parameters fused to that data. For instance, if you have a temperature sensor, you can't just log analog values of temperature without even time stamping it. At least you have to have a timestamp of what you read. That in other cases. You have more than one sensor. By one sensor data alone, you cannot comprehend what is happening in the real life scenario there. You need to have fusion of data, which is like combining all them together in one lump and get some meaningful information out of it. And then once you get the data, where do you store it? You want to store it in the device or elsewhere? These are going to be questions asked by this embedded systems engineer. He's looking at the requirements by asking these questions. Am I going to store this data in the edge device itself or into the cloud? All right, another one of this cartoons. All right. So we talked about data and information. There are two different things. Data is not information. You have to convert data into information. For example, devices produce enormous amount of data at incredible rates. For instance, as the Boeing 787 engine produces half a terabyte of flight information from sensors. How do you process all these things? How do you get any information out of this? You have bits and pieces of information, so you have to categorize them, organize them, store them for easy retrieval of data, etc. Also, there is a method called data scrubbing, where you clean the data by removing invalid and repeated entries. And then you organize them in structured data sets if you are going to use a traditional database approach, or unorganized data like NoSQL, MongoDB kind of a deal. So you store unstructured data sets without any schema and things like that, but you just keep collecting it and leave it to a machine learning algorithm or analytics to look into it to give you meaningful decision-making capabilities. All right. Okay. So there are people who say the answer is cloud for everything. So this cartoon depicts that. But for our discussion, we are going to move away from cloud, and we are going to say cloud, since we expanded our computing resources to a distributed computing paradigm. Cloud is another computing resource which is not in our premises. It exists somewhere. Just sweep it under the carpet and say like, okay, it is there, and it takes my data and keeps it there. I can access it anytime I want. I can put some processing logic over there instead of pushing everything to embedded systems devices. For instance, let's say there's one advantage you all would have already realized that devices are going to be millions and billions of them. But then if you have to update software on them, you can't do it a million times. You could somehow do it in once and hope that it works from the cloud. So you could deploy firmware updates from cloud. I'm saying only this because we are looking at a embedded systems perspective. That's why it is. This is the point I want to stress on here. Don't mistake me here. Cloud is more than what that we talked about. It has virtualization, containerization, platform as service, software as service, infrastructure as service. You can have microservices, which will do all kinds of stuff. We use it every day, but for this talk, it is not relevant. All right, so let's get to work, and we will start designing a device and a system. Okay, so hypothetical. This is from now on. It's not no more of theory. We're just going to get our hands dirty here. Let's define our area of work here. So devices, connectivity, cloud, and application. So the embedded systems engineer is more interested in the devices and maybe up to the connectivity side of it, not so much as cloud and application layer, even though we will be talking about that a little bit, because the embedded systems engineers cannot shut themselves down that, okay, I'm not going to listen to any of these cloud application engineer discussions. He can't do that. He is in the design team, and there are subtle information everywhere. So just open your eyes and ears, get in all the information, and then try to incorporate all that in your design. So this is a typical IoT product offering. We have devices, connectivity, and in the cloud, where we have the application also runs in cloud. And more often than not, we access those applications using our web browser. Anyways, okay, so this is the device we are going to design today. Well, this is testing time for us. The pandemic is really creating havoc here. So we'll talk about a device which is going to monitor our vital statistics and collect data on a person who's wearing it the whole day. And basically, this data can be then transferred to cloud or cellular data or any other connection possible. We're going to explore that, how we're going to design this for further analysis and reporting, etc., by healthcare professionals or anyone that has valid reasons to have access to this data. To build this IoT product, first, let's assemble a team of engineers. It is not a surprise that our embedded systems engineer is also part of this team. Okay, so let's talk about this device. How is it going to bring data to the cloud? Let's hypothetically say that this device is worn in your ring finger, and it talks to your smartphone, and the smartphone in turn talks to your cellular network. cellular data network. The team. So this is my belief in my company. I always had one person who knows everything from the top level perspective to minutest details of the product which he or she is building. So under that person, I mean, it's not hierarchy like under and all those things, but that person helps or feeds to these two teams. This is a very simplistic model of a team for our discussion purpose here. So it's an embedded systems team and cloud team. So of course, embedded systems team has hardware design people and firmware development people. So we have this as a team, let's say. So our embedded systems engineer is going to be an embedded systems team, and let's say he is doing hardware and firmware. He's just borderlining between those two. Okay, so the embedded systems engineer heard, as Dr. Ushaa Eswaran was pointing out, our company here, we get one-line description of products people want. They come to us and say, okay, I want to have a vital statistics monitor. That's all they say. I mean, they don't say, where do you connect this and how do you want this and all those things. So we have to ask questions now. So that's what this team is going to do. What are the requirements? What kind of computing power needed? So this is the embedded engineer asking, what kind of computing power needed in this device? And what kind of sensors are needed? How are these sensors going to be interfaced with the computing element? What kind of processing of data to be done in this device? Physical size of this device? How is data transferred to the next point in the line of data travel, and where is the data going to be stored? When I put together this slide, I had a fun fact here, which I want to share with you guys about this ring. Westerners wear wedding band in their ring finger. There's a story that it says simply because there is a vein that directly goes to the heart. It's called vein of love. Vena amoris is the Latin word for that. So that goes directly to your heart. That's why you wear it. Okay, fun fact. I don't know how this embedded engineer is going to use that fact, but there it is. Okay, so the picture here in this slide, it is a real life microcontroller from Microchip Technologies. Look at the size of it. So we have hope now. You know, when I was starting as a hardware engineer, a microcontroller filled a board. Basically, you have to have a board that constituted a microcontroller with its RAM outside, ROM outside, all that big. Look at that. I mean, this is a self-contained microcontroller with its own memory, program memory, RAM and everything there. And it has peripheral interfaces like buses, like I2C, analog to digital converter, all those things. This is incredible. This is why our IoT is gaining a lot of traction and momentum. We are in the right time and right place. We wouldn't have done this even though we had all these ideas. That's why I said that nothing is new in IoT, but the time has come to IoT to realize its potential. Yeah, so we talked about the size of the computing element here. You know Moore's law, so well, it is really working. This law is one law that that has been not proven wrong until today. This is great law. Anyways, power requirements. You have to power electronics. Unfortunately, we need power for electronics. How are we going to power this device? So this embedded systems engineer is asking this question again. Are we going to power this device with a battery, or what else is there apart from a battery? Yeah, so there are super capacitors which you can use, and you can keep them charged like a battery as well. The the line between super capacitor and battery is very blurry, so we don't have to go there. Anyways, so this engineer is also thinking about energy harvesting, because you are wearing this in your finger day long, and it's in contact with the human body, which has got temperature, so you could harvest that energy. Or I don't know how many of you are are that old enough to know there was a watch called a Seiko watch. It never had, you never needed a battery or any keying mechanism. It just worked by moving your hand, you know. It's worn in your wrist, and because of the movement in your wrist, and it charged, I mean, it's mechanically stored its energy in a spring, and it worked day long without any problems. Anyway, that is energy harvesting like 30, 40 years ago. So now energy harvesting is different. We harvest energy from vibration, heat energy, RF energy itself, piezoelectrical effect. When we looked at that ring, we need to we need to charge that battery as well, right? Battery or whatever is there in that device. So this engineer is considering maybe a wireless charger for this, because it is not practical to have a connector on a ring, and it's not going to look nice. So he's deciding with wireless charging for this device. Okay, let's keep going. So choice of network here, that's handed over to him already. So he is, the team has decided to use the cell phone as the network. But then before that part of the network is addressed, your device has to connect to your smartphone. You can put a Ethernet connector to this ring, but there are two other options, three other options: Bluetooth, Wi-Fi, NFC now. Every cell phone has all these three. I mean, not every cell phone. Most of the smartphones have Bluetooth, Wi-Fi, and NFC. Wi-Fi is kind of power hungry compared to other two technologies. So we're going to just say, also it is a little bulky. So we're going to say, this engineer decides, no, it's not a Wi-Fi design. It's either Bluetooth or NFC. NFC, you have to be really close to your phone. So that means that data transfer has to occur cannot occur on demand, but intentionally, like you have to bring your finger next to your phone or something like that. So that is not an option. So we'll go with Bluetooth. So the engineer decides to have Bluetooth here. Network protocols, which one to choose? This question is already answered when he chose Bluetooth, because Bluetooth comes with its own protocol, which we will address in the next slide pretty soon. All right, challenges in networking. So now, what is the challenge in okay, the first point is how to identify data source. So meaning you are designing a ring, and you're not going to expect only one ring in a crowded room. maybe your product is taken off so well and everybody is buying because everybody wants to monitor COVID-19, and everyone wears. And how do you identify which ring is communicating and which is sending data? So you need to have some kind of addressing mechanism there. Bluetooth has its own addressing mechanism, but then this engineer is looking at talking to this is where the team involvement is right now. The team decides to have IP level communication instead of Bluetooth protocol layer communication for easy processing on the cloud side and all those things. So they are saying like, okay, we need IP level. Somehow, somewhere we have to convert this to IP. So this engineer looks around and he sees that IPv4 is exhausted already, and so he decides to use IPv6, which is six-low-PAN very nicely integrates Bluetooth data with the IP technology. So he decides to use that. So he has to also decide how to make sure that data reaches without getting lost to the cell phone. Bluetooth has its own error correction and error detection mechanisms, but you could also put some more application level error detection and correction as well. The embedded systems engineer decides about, he has to decide about what kind of error detection and correction he can keep in his firmware. What is the other end of the network? In this case, it is your smartphone. Who owns the network? That is not a question at all. Out of when the data leaves the smartphone, then it goes to the provider. These are philosophical questions. You don't, I mean, the embedded systems engineer just listens to these questions, but then he doesn't have to act on it. The reason why I put it here is that the engineer hears a lot of inputs, but he weeds out what is needed for him to make his decisions and leaves out the rest of it. Yeah, so this is what I was talking about, IPv4 getting already exhausted. Look at the amount of devices which we are anticipating in this year, like 50.1 billion devices. It's a phenomenal amount of devices. They all need to be addressed and properly communicating to the network. Okay, a little bit of talk about data security. Any embedded device you devise, you need to take into consideration what kind of security measures you're going to take for your data. If somebody says our product is totally secure, no, don't buy into it. Total security is a fallacy. Superior security is achievable. You could say like, okay, we did this, that, and we have patented IP on this. That's why this is superior security. Yeah, okay, I buy into it. So security protocols, you could, we discussed about that in the Bluetooth decision when the embedded systems engineer made. You could put that security on the transport layer or on the IP layer or in the application layer itself. So the application layer security, for example, is PGP, just to think of one. I would be, my company is very much into security. So I can devote another hour talking about this security, data security, symmetrical data encryption, key encryption, public key, private key pair, authentication and authorization. don't get me started. So let's keep focusing on, because I look at the time and it's only 10 more minutes, Dr. Ushaa.
No, you can carry on as long as you want.
Oh, thank you. Appreciate that. Okay, so in that case, we'll just talk about. No, I mean, we have some more slides here, so we'll come back to it if we have. Oh, okay. I am almost there, actually. Yeah. Okay, so symmetrical key encryption. I don't know if you are interested in this, but anyway, I think it is a very important topic to talk. So I will wait until question and answer session for this. We will have to come here. Now say the embedded engineer has all kinds of requirements put into his, I mean, he listened to it and he asked his own questions, and he's come up with a list of ideas on how to do this and all that. So he's going to go sit down and put them all down into a document, which is Systems Requirement Specification, SRS, which is a very key documentation we insist in our company to have. Any team which is working on a product development has to have their SRS. So it's like this is the way we ensure that you plan your work and work your plan. So you first plan your work and work on your plan. Most often than not, we see, you saw that ring which we are designing, it is so small. How do you even debug that thing? So these are important factors to consider how to debug. I mean, the embedded systems engineer's point of view, this device needs to be debugged somehow. So he's thinking of devising this entire thing using bigger boards or components for proof of concept. He might have like several different boards, evaluation boards and things like that bought out, and he can wire them up on his bench, test bench, and then he can write firmware to it. And then finally, once he's happy about all the bottleneck areas which he thought he needed proof for, he can put them all into a minimum viable product design, which is a prototype design kind of a deal, where he can go down in size and make a real life product. During this proof of concept phase, you can make build buy decisions. Engineers tend to be tempted to build everything by themselves. I'm guilty of that, actually. So it is very interesting to build, but if you could buy them outside, just go buy it, because you are also not given this project for your lifelong interest. It is a product which has to be delivered. So make that build buy decision wisely. Sensor selection, input and output. Well, the sensor selection here, when you select a sensor in our ring, you saw that microcontroller element, which is so small, and there are only a few pins there. If you want to have a connection to that to a sensor, it better be communicating with a minimal number of wires. For instance, there are one wire data interfaces, or two wires, which is I2C, which is a very common and interesting buzz. So let's say the engineer decided to go with I-squared-C on that. Offloading, I don't know why this is here right now. So offloading is a term used for, I mean, it may not be applicable for our ring design here, but whereas, let's say you are using a Wi-Fi communication module in your design, you don't, when you say Wi-Fi, it is IP communication. When you talk about IP communication, you have to have a TCP/IP stack and all those things in your firmware, which is a big deal if your firmware. I mean, if your microcontroller is this small, and most often than not, it is resource constrained situation there. So you don't want that TCP/IP stack and all those things filling up your program, precious program memory. So you want to offload that to the module which is responsible for that communication needs. That's why it is there. Okay, do we need a RTOS or bare metal is enough? This decision is a very crucial decision in embedded systems engineering context. Bare metal is enough in many cases, but then as we learned it by experience in our company, the users innocently come to you and say like one line and say like, yeah, this is what I want. And once you come up with the system requirement specifications and all those things, we involve our users in all this documentation as well. We follow agile product development concepts here. So we involve them in every step of the way. So as we develop this system requirement specifications, they're going to come back and say like, yeah, what if we have this? What if we have that? So it's a kind of a scope creep, keeps creeping into you. And before you realize your bare metal firmware is like complicated, and you're like, why am I doing this? I want to end my life. I don't want to look at this code anymore. So RTOS would be a good idea for that. Actually, we have experience in that. So I think with this, we know that I think we did a good job in designing this ring. And the IoT product, I don't know. I mean, I have to hear from you. Until I hear, I'm going to assume that we did a good job.
Demo,
so,
Raja?
Yeah.
Do you have a demo of any?
I don't have a demo. I can show you some of the products we developed so far, and I can talk about that each one of them, and we can interactively go over it. That's what I thought. So if that is okay with you,
do you have that ring with you?
No, no. It's a hypothetical product actually. Okay. So I just thought that what if? I mean, we are. I just wanted to design new thing right in front of you guys. So that's what I did actually.
But Raja, with this IoT and these rings, can't we have something like a social distancing? Can't we implement?
Absolutely. We've been talking about that too. But the problem in US is all this privacy and all those things. These US people are fanatics about privacy. Maybe it will work in India. I mean, you tell me, we can design that ring and we'll put it out in the market.
I was working on doing something like a proximity sensor with a band in the hand to have a social distancing, especially for the school kids.
Yes.
Like in Kerala, they were using umbrella to have a social distancing. So kids will not follow all those things. So if they have a band, in which you have a proximity sensor and you are able to identify some distance, like you're closer, some sort of alarm or some sort of vibration, which will help the children to move from that area, right?
Yeah, we were discussing these things. I mean, we have a IEEE group here, so we just sit and socialize, not sit anymore because it's all online now. We we came up with a similar concept where you wear a hat and there is a big speaker. It says, "Don't come near me. You're creeping into my social distancing circle," or something like that. So
So
yeah,
hundreds
similar
of
concept.
people, then it
Yeah,
will be a noise pollution, right? So
yeah,
I wanted to do something for the schools, the school children, to be safe when they are in school.
we'll talk. We'll
So
talk.
yeah, I really wanted to. I was discussing with my son that we should do something like that,
Yep.
and you have a question from Subbu Venkatachalam in the chat box.
Okay. Where is my chat box? Should I?
Your
I think I
IoT
should.
box.
Okay. Where do I? Well, I have to stop
Yeah.
sharing first.
So, Dr. Raja, I can ask the question if you want.
I'm not Dr. Raja, so I'm
Uh,
just a
No, more
tinkerer
than
here.
that, Raja.
No.
yeah.
Yeah.
Go
Yes,
ahead, sir.
you
So,
can.
so, so, Mr. Raja, this is great. I just want to thank you for this a great presentation because it lines up with what I'm going to talk about tomorrow. And I was so glad
Okay.
you brought the ring in because I was doing some research last night, and it's funny that I found something about the ring being like an abacus ring from the Chinese. I'm just looking at
Okay.
that right now, from the 1644 Ying dynasty or something like that. So
Okay.
yeah, I can send it to you later. It's
Please
called
do
the
so.
abacus. Yeah, yeah, yeah.
Good.
But my question is, I'm in healthcare. I'm fascinated by the sensors you were talking about. Can you elaborate on where we are in terms of the growth of sensing devices? I know they can do temperature and some vital signs, but are they at a technology perspective from smelling and all the other senses? Maybe you can add some clarity on that.
Well, yeah, smelling is still um, in nascent stages, I think. They um, a group of people they came to us and said well, we are building a IoT device, which is you plug in there. They wanted to sell essential oils, and then they wanted to have a app communicating to that device, which is plugged into your wall plate, and it emanates this, it evaporates this essential oils. They want to sell the essential oils and the device. But I mean, I'm digressing a little bit from what your question is. I don't think we are there with smell. But as you pointed out, IoT, the most of the innovation is happening in the sensor arena than in any other place, because all the other technologies used in IoT are uh, um, old technologies which existed and it's been repurposed for this um, business model. I, I I don't know if I answered your question, sir.
No, no, you did, Dr. Raja. Yeah, yeah, fascinating. I connected with you on LinkedIn. We can talk offline, sir. This is great. Thank you.
Thank you.
Raja, can you stop sharing? Let me see you on the big screen.
um, you, do you want me to go over these devices quickly,
Yeah,
what we did here?
why not? Yeah, go ahead.
Okay. So this is a very recent design we made. This is I can show you physically these devices here as well. So, anyways, let's talk about this. This is a end-to-end system. This device has a microcontroller, of course, and it has a Wi-Fi module. It has a Bluetooth module. It has a GPS inbuilt GPS sensor. It has 9 degrees of freedom of movement, like 9 DOF accelerometer, magnetometer sensors, and it is powered off USB. This particular device, what it does is it maps your room's RF energy and then creates a signature that signifies that location for you. Meaning, let's say you are a defense contractor and you want to access defense computers, but then Pentagon and those people, they don't want you to be accessing these computers from somewhere in Kabul or some boony areas, questionable areas. So they want you to be authenticated based on where you claim you are connecting from. So that's this device we designed for a company. This creates this is where all the security comes in. I can take it offline and we can talk about this, because this is a fascinating device. Okay, the next device. This board is in this casing. Basically, it's I can show you later when we stop sharing the screen. Okay, this this is a small module for another company, which this company is a OEM manufacturer of lighting controllers all over the world. People buy from them. Philips, Cree, Osram, all these controllers are from these guys. So they came to us and said, like, we have 3,500 different models of our controllers, and we would like to somehow minimize them to some manageable proportions. And we said, like, okay, we'll put a microcontroller in there, and we will make the hardware configurable using code. So we came up with this kind of a module which plugged into their existing the lighting controllers. Thereby, they were able to reduce their amount of inventory by 350. Actually, each one of these boards were able to configure one physical hardware into 10 different products for them. And then this was configured using a satellite configurator, which is nothing but a Raspberry Pi computer, but it has a touch screen and all those things. It's this is a Linux embedded Linux we cooked up ourselves with Qt framework in it. So this is what we did for another company. This is another interesting product. It's a wearable device. You could wear it as, I mean, this is long time ago. That's why you see those big LEDs and all. And this is a MVP, minimum viable product. This is not the ultimate product. This is a kind of a badge kind of a deal. What happens is if you've seen big cruise companies, they have cruise ships where the people go on a cruise ship, and they drop those people in remote islands where they can go around, do whatever sightseeing they have to do, and then they have to come back to the bus to go back to the boat. Most often than not, what happens is one guy will be missing, the whole group is waiting, or everybody is here, and I mean, there are many problems. you might ask, like, I mean, everybody carries cell phones. Why can't we call them? But the problem is, as I said, these are all remote islands and places like that. There are no cell networks, nothing. You just go there and walk around. So we came up with a mesh networking concept. So as everyone carries this, they form a network. So the network is deployed as you spread around. So you could, the coordinator of this group can press a button, and then that will communicate signals to these people. Also, there is a GPS module on board in this device, using which you can also track them on a map, saying like, okay, this is where they are. Okay. All right, this was an industry for, this is, we designed this, board 8 years ago, actually. We thought, we knew that this is going to be a growing field to be. So we came up with a very general purpose board, which had 4 digital inputs, 4 digital outputs, and 4 analog inputs. Some analog outputs also there. So we had a Bluetooth, Wi-Fi, and a cellular radio on this. And also the important thing about this device is this device had a rules processing engine which is built into that device itself. It's a powerful edge device. It's I mean, way ahead of time at that time, and we couldn't get funding to proceed with this real product. We miserably failed in that doing. I mean, we proved our incapability in marketing this device. Anyways, all right. So there you are.
So I could hear Raja talking technically after 30 years.
Oh my goodness.
Yeah, I used to admire you when I was a hardware engineer, trainee engineer. When you used to design all those, I learned everything there only. All the breadboards, soldering, the LEDs, and the way you used to vary the design and see that the barcode reader senses. Oh my God, I'm just going back 30 years.
Yeah, it brings back nostalgic memories. Yeah.
That was a wonderful memory. I really admire your knowledge. I always used to admire your knowledge, and now that it's too much.
You know, if we think about this, that's what I was saying in my presentation, that build buy decision. During that time, 30 years ago, India was not open for foreign technology. We had to come up with everything. That's when you and I started. So during that time, we had to develop everything by ourselves. It's not buy decision was not there given to us. There was no way you could have bought all those things. We designed our own barcode sensors and barcode readers. I mean, we had a LED pointing out and a phototransistor reading it back and things like that. It was fun.
Really, still the memory is green.
Thanks.
Because I just finished my engineering and I joined as a trainee engineer. I just don't know anything.
I remember.
I started learning ORCAD, designing the PCB designs and production. All those things are experiences really made me feel really great. And
you are a humble person, Ushaa.
and I must thank you, Raja, really for all-time guidance. It's not that we worked, and how many of them are in touch with their first boss?
Oh my goodness.
And I'm very happy that all our teammates are also in touch, and it's really wonderful to have such a team. I mean, we really had an emotional connect too, though we were technically connected. It was really
Thank you.
That was really wonderful. And till date, you're always my moral support, an encourager, always. That adds a lot of value to
You're
whatever.
doing great. So, yeah.
Who says it? That's a problem here, you know. So, someone need to encourage you, motivate you. You need somebody to really understand you. And I would request the participants to ask some questions. And how did you feel about the session? You can give your feedback to Raja.
Uh, Very good evening, sir, and probably good morning to you. I am Shanmugan from
Yes,
here
yes.
from Anna University.
Uh-huh.
As a mechanical engineering myself, teaching new product design, I could relate how you were able to identify the customer need. Probably even in this pandemic, you took up an example of a very beautiful ring, and through the concept development, concept generation, selection, and testing, how beautifully you are able to form and with the teams you are able to come out. So I was really fascinated, and I just wish to compliment as a mechanical engineer. We look at how we involve ourselves in the product development.
Thank
Probably
you
the
so much.
embedded system was, or the IoT, of course. Professor Pradeep is also there in this conversation. We had a small IoT training workshop for everybody, and our College of Engineering Gindi students were able to come out with when there are dustbins that are being filled up, it were able to give a feedback to the Commissioner of Chennai. So that
Oh,
is the
great.
level at which the IoT is been penetrating into the engineering education. Probably as a mechanical engineer, I just wanted to, because you are also into product development. How is the additive manufacturing giving you an impetus in making your accelerated product development?
In fact, I had a slide of our 3D printer here. We have a 3D printer in our office. Basically, we print all our gears and the enclosures in our 3D printer, basically. So additive manufacturing is taken off like anything. I mean, especially as you pointed out in IoT area, where enclosing your design in in forms and fit which never existed before. So as a mechanical engineer, I'm sure that you would appreciate that.
Yeah, that's true.
Yeah, rapid prototyping is possible simply because additive manufacturing.
Okay. And probably one of my requests is yesterday also we had a very sad news that in Chennai, one of the scavengers who have been used for manual scavenging has died because of probably what you call the chemicals that come out. So if you
Okay.
could try to come, as Madam was trying to talk about social distancing, I thought I can request you, because I don't think people have started to give a solution to this permanently. And this manual scavenging, there is still there. Can we come out with IoT device, or using your intelligence of robotics and something else which can totally eliminate this?
Well, I don't know. In here, the there are trash trucks which come in every week, and you take. I think it is a social problem as well. You notice that um, people here diligently.
Carry on, Raja.
Okay, so um, people diligently follow rules and placing their trash in a container, and then push the trash container to the curb for that truck to come and pick up without manual intervention. A little bit of manual intervention, but then it just deploys a robotic arm, and then it just takes it up and throws it in the trash, and it compacts it inside, and it takes it to the dump. Um, so in a sense, this is mechanized here. with um, the society also contributing to that kind of a disciplinary thing. I remember, I don't know what is happening now in India. Um, um, when I used to live there in Chennai, um, people just toss their trash out, and they don't pay any attention to. I'm not here to talk about social ineptness and all those things, but to answer your question, sir, that there are mechanisms available, but how to deploy it is a question. I would like to hear from you more about what do you think about that, sir?
Yeah, that's true. Yeah, probably since more things are becoming mechanized and uh, using these technologies of IoT, all those things, I believe that because as mechanical engineers, we would be able to come out with mechanical uh, devices, but in using the IoT and all the other stuffs, uh, uh, not much of interdisciplinary research is found in regular engineering colleges. Probably at Anna University or higher universities and IITs, it is there. But probably you could. I'm just giving you a problem that if there is a possibility of designing these kind of devices at low cost, this could be a contribution back to India. That's what my humble suggestion to you
Yeah,
is.
I mean, you already are involved in that, so we should learn from what you learned, and well, we should be able to apply our experience and come up with a cost-effective solution. Yes,
Yes,
we can
thank
work
you.
together on that. I mean, we are open for that.
Sure, sure. Thank you. Thank you very much.
Thank you so much. And many participants have thanked you, Raja, for your wonderful presentation. And we have been always talking about IoTs, but we have seen a real man who is working on IoTs and bringing products. It's an inspiration. And when you visit next time, we can also see like who will be interested to collaborate and do something in, in your area of expertise. And can we have all your videos on so that we can have a wonderful picture with Raja? Wow, that's wonderful. Please, I request all of you to turn on your video. Please turn on your video, all of you. Some more.
Able to open my video since you have stopped my.
Acha, what is your name, sir? Sir, can you give your name so that I can enable?
Moving.
Ah, yes, sir. So during that session, I would have muted. I'm sorry. You can turn on your video. Anybody else?
I'm also
to turn on your video.
I'm also getting the same problem, ma'am.
What is your name, madam?
Ma'am, Sai Kusma, ma'am.
Sai Kusuma, 1 minute. Yeah, because initially when you joined, you started with the video and you were talking. So I had to, I'm extremely sorry for that.
Okay.
Try now, Kusuma. Sai
Okay.
Kusuma. Please try to turn on your video. Yes. Wow, wonderful. I think one Miss Deepa is yet to turn on her video. B. Deepa, Pradeep Kumar. Dr. Kachendra Kumar, sir, we would like to have you on the video. Afsar, sir, please turn on your video. Yuvraj, Nivedita, Chandra, Shavani, Rajarajeshwari, Narthana Krishnaraj, please turn on your video. Ramesh G. Nachiepan. Wow, that's great. So smile, please. Thank you. Thank you so much. That was wonderful evening, Raja, with you. And people who are really working on IoT would have gathered a lot of info from you.
I
And
hope so.
just taken us in a path as if we are designing, right from the team selection. That was wonderful, like a story.
Thanks,
So,
Ushaa.
thank you, Subbu, for wonderful questions. Thank you, sir. Shanmugam, sir, for your wonderful question. And thank you, all the participants. All of them have given their chat box. They have mentioned it was wonderful, and they've conveyed their regards to you, Raja.
Oh, okay.
So many people have written they were very happy with your presentation, and they're thanking you for a wonderful informative session.
I wish we had more questions.
Yeah. Next time, maybe we'll have more questions.
Sure.
So thank you. Thank you so much. We'll meet tomorrow with Subbu. Hi, Subbu. We'll meet tomorrow.
Yes.
I'll be there.
Okay.
Yes.
Thank you. Thank you so much. All the participants.
Thank you.
Thank you so much. Good day.
Thank you, Dr. Ushaa.
Bye, Raja. Bye.
Bye.